Now we need to create the floor for each of our levels. In order to be able to create a floor, first off, we want to make sure that we're in our second floor view, because that's going to be the first place where we're going to be putting this concrete slab on top of. Now, the next thing we want to do is move up here where we see structure, and then select on this little picture. It looks like a floor. When we do this, it'll automatically execute the floor tool for us. Underneath properties, we have our type selector list. If we select on that type selector list, we'll see a list of all the different kinds of floors that right now we could possibly use. In this case, I kind of like the default one, which is this 3-inch lightweight concrete on 2-inch metal deck. So let's go ahead and just use that. Before we even start drawing the floor, we're going to want to put an offset value to this floor. In this case, it's going to be whatever the thickness of the floor is. And we have 3 inches and 2 inches, so a grand total of a 5-inch thick floor. And that offset value is going to be here where it says height offset. And the reason why we're going to put this 5-inch value in here is that we want this floor to be sitting on top of that structural steel, which is hosted to that level. So go ahead and just put that 5 inches in. Next, we need to draw out the border for this floor. And we really have 2 ways we can go about doing this. The first way we could do it is by moving up here and just picking the supports. But if we do that, we'll have to click and click and click and click, and we'll have to click about 16 times all the way around. The fastest thing for us to do will be to move up here to the rectangle tool and select on rectangle. Now I'm going to zoom in just a little bit here. And I will point out that technically I could add an offset value right here. And the reason why I mention that is that the first place we're going to click is going to be right here at this A-1. And in reality, we really want this to be coming out about an extra 6 inches out in this direction and 6 inches out in this direction in order for our floor to be able to cover these beams which are going from side to side and up and down on our screen. But what I'd like to do is just show you another property that's related to this. So I'm going to kind of draw it a little bit differently than how I normally would, and I'm not going to add this offset right away. So select right here where we have the A and the 1, move back down here again to where we have this intersection down here, and go ahead and click. Once you have that colored line going all the way around the perimeter of your structure, come up here and click on the big green check mark. And that'll automatically place a floor in that location. Besides the fact that it's blue, and if we click off of it, you won't be able to see that blue anymore. One thing that's going to tip us off immediately that there's a floor there is the fact that we can see our beams through the floor, but it's also showing up as being dashed lines. And that's going to be the correct representation we want to be able to say, hey, there's a beam showing up there underneath our floors. But the bad thing for us is, and as I kind of mentioned, is that it actually drew the floor right around the perimeter of where we drew that colored line at. And since we didn't set an offset value to it, it drew it exactly on where that line is at. The good news is even after it's been drawn, we can still set some sort of offset to it. To do that, all you have to do is select back on your floor. And remember, to select on an object, your best bet's always to select it near the edge. So I went to the edge of the floor and clicked right along the edge of the floor. Then you can come up here to the Edit Boundary option, click on Edit Boundary. We don't have that offset value after the thing has already been drawn, but what we can do is we can move our mouse up until one of the lines is highlighted. Then click on the Tab key once. By doing that, it's highlighted all the lines that are touching each other, which are all the lines that make up the perimeter of our floor. Go ahead and click there. Now all the lines that make up the perimeter of our floor are now highlighted. Once we've done that, there's this option here that says cantilevers and concrete. Now change this to be -6 inches. And what this is going to do is it's going to put 6 extra inches, in this case, to the outside of our floor. Once you've done that, go ahead and click on the big green check mark, and we'll start to see those results here in just a second. One thing I'll point out, and if you've clicked on the big green check mark already, that's okay. But I will point out that as soon as we entered in that -6 inches, we can now see this dark black line going around the perimeter. That's where our floor is going to be designed or where it's going to get built. Go ahead and click the big green check mark. And now we can see that the floor is now stretching over the top of all of our beams, and it's in the location where we want it to be at. One more thing we want to do is we want to be able to copy this concrete slab up to each of those other levels. So As long as it's highlighted blue, we can go on up here to the copy command. If it's not highlighted blue, just come over here to the edge of your floor and click, and it'll highlight the entire floor blue. Then come up to the copy command. So copy the clipboard, and then we're going to go to paste, and we're going to do align to selected levels. And we're going to tell it which levels we want to have this floor pasted onto. In this case, we're going to do it from the 3rd floor up to the 9th floor. The 10th floor would have a roof structure put on it, so we don't need to worry about that. Once you get that, go ahead and just select on OK, and it will copy that floor as we created it up to each of those other levels. In fact, if we take a look at this in a 3D view now we're not really seeing much right now, but the reason is because right now the visual style is set to wireframe. But if we change this to be a shaded visual style instead, we can see each of those floors, and they've been copied up level by level up here. In fact, if we zoom in by just using the wheel and the mouse, we can also begin to see why we added that 5-inch offset right at the beginning where it said height offset, because that's the thickness of the floor, and we offset it from being flush with the top of the beams, and we offset it 5 inches so it's sitting directly on top of the beams now. So the key to doing your floors is to draw their profile shape exactly the way that you need it. Then, if you have a multi-story structure, you can simply copy each floor up to their appropriate levels. Creating a floor style from scratch is easy in Revit as long as you understand the principles about how a floor is actually constructed. And really that's what this video is all about, understanding those principles about how floors are put together. Now, in order to be able to do this, we're going to come up here to Structure and then select on the Floor tool. And it doesn't really matter if we do a structural floor or an architectural floor, which is just a structural floor without any of the actual forces and loads associated with it. But I'm going to pick floor structural here. Here we can see that we have a floor 3-inch lightweight concrete on 2-inch metal deck. Now, in order to be able to see the properties of this floor and understand better about how it's constructed and put together, all we have to do is move down here to this button that says Edit Type and click on that. Then the next thing is going to be Edit Structure. So always remember, you need to modify a floor, do Edit Type, then Edit for the structure. And this will bring us to the Edit Assembly dialog box. Now, there's actually more to this dialog box than what we're seeing here on the screen. In fact, that's the reason why I clicked up here on the top and then just pulled it over to the side. It's because down here at the bottom, there's this big preview button. And if you select on that, we'll see a preview of what this floor is going to look like if we would take a section through it. Now, this happens to be actually each layer material that's going to be associated, in this case, with this floor. By the way, if you ever have this material metal deck and that's what's selected, what this does is it'll automatically assume that this little bump structure here, which happens to be the shape of the metal deck when it's put into place, exists, and it'll automatically try to put that in your floor. The actual structural part of this happens to be the concrete, and we can see that it's currently listed as being 5 inches thick. If we wanted this floor to be thinner, we could. All we'd have to do is change this 5 to be something smaller, such as a 3, and then just click someplace else. And you can see how now this floor is much thinner. If we needed that floor to be thicker, we could do that as well. Now, what just happened here is that we can see that this is what's called the material browser. And it was brought up because I clicked inside of this concrete dialog box. What this does is that it allows us to change whatever material we want associated with this floor. So if we wanted a different kind of concrete, if we wanted to have steel or whatever, like in this case we can see the metal deck material, it would just be a matter of picking the appropriate material off of the list, and then that floor would be built out of that material when we model that floor in Revit Structure. Now I'm going to go ahead and click on Cancel this dialog box in order to be able to get out of it. There's also a function feature here, and right now it just says Structure. But you can see that there's different layers of material. And usually whenever we're dealing with this, it's probably always going to be structure for you related to floors. But these same different layers of materials are also available to you if you're going to be building such things as your walls. And for what it's worth, your walls have almost the exact same dialog box associated with them, and they're built the same way as your custom floors are. Essentially, it's one layer of material, then another layer of material, and another layer of material. Now, back specifically talking about floors, if we wanted this to be back to just being a 5-inch thick floor, we just type in 5 inches here. We'll need to click somewhere out in space in order to be able to make this actually get its thickness back again. If we wanted to have another layer of material placed on top of this, perhaps there's another thin layer of concrete, or maybe there was a flooring material on top of this, all you'd have to do is select on the Insert button right here. You would add another layer of material, which you could either move up to the top or down to the bottom by either hitting up or down. Then if we wanted to give this a certain thickness, we could. If we wanted to have another 2 inches of thickness associated with this, we just add perhaps a number 2 here, click in this box, and now you can see there's another layer of material. It doesn't know what it is yet because we didn't click in this by category box yet. If we wanted to add that layer of material, tell it that it's a certain layer, just click in here where it has material, and then pick off of the list whatever material you'd like to have associated with it. Now, I realize this is going to be a thick piece of carpeting, but I'll just select on that just so you can see it. And you can see now that it has that carpet material on top of the floor. Well, in this case, I don't really want to make a change to this particular floor, so what I'm going to do is I'm going to come down here and click on Cancel. But if I like the changes that were made to the floor, technically I could just click on OK and it would save those changes, and any place that floor would appear inside of our structure would automatically have those materials added to it. In this case, though, I like my floor the way that it is, so I'm just going to click on Cancel. One last thing I wanted to mention is that changing those properties inside of this dialog box, and you'll remember Edit Type, Edit Structure. What happens is that it'll change that for this particular floor, or whichever one you currently are editing, throughout the entire project. Oftentimes, that's not what you're going to want to have happen. Most of the time, in fact, you're probably just going to want to create a floor essentially from scratch. In order to be able to do that, all you have to do is come up here to Duplicate, click on Duplicate, give that floor whatever special name you want to give it, something that makes sense, something that indicates what the structure of the floor would be. In this case, I'm just going to call it Example. You'd click on OK, and then go to Edit Structure, and then add or subtract materials as need be. So when it comes time to customize your floor style, just remember you have full control over all of its properties underneath Properties, Edit Type, and then Edit Structure. Openings are not just empty areas in Revit. They're actually entities created in Revit which can do everything from creating wall penetrations to openings in floors. In this example, we'll create an opening for a future staircase that we'll be placing in our structure. So first we need to actually find the spot inside of our building where that future staircase is going to be at. In this case, I know that it's going to be around column grid B here, so we'll go ahead and start to zoom in here where column grid B is located at. And I know that it's also fairly close to column grid number 2 here as well. So we'll zoom in, and I know that it's going to be right in this area because it's right to the right of where number 2 is located at. So we're going to be placing an opening object inside of this space. So to begin with placing the opening itself, we'll need to come up here to where it has Structure, then move over to the right-hand side, and we're going to look for our openings. And this particular one is called a shaft opening, and it's good for such things as staircases as well as places where you might place elevators at. So we'll go ahead and select on shaft. Next, we'll want to start to draw this in. Now, I happen to know that this happens to start off about 1 foot off of where this beam is placed at. So in order to be able to do this, we'll start off by using the line work tool, but we're going to set an offset value to this line work tool. So when we start to draw, it's going to actually place this first line 1 foot away from where we're drawing the line at. So we'll select Offset 1 foot, pick the beginning spot for where this line should be, and then move straight down. If for some reason the line is on the other side, it shouldn't be for you, but if it is, you can always hit the space bar to flip it to the appropriate side. So just make sure that it's on the right-hand side here and then come straight down. And this sort of pink-purple line here is offset about 1 foot from where we're currently drawing at. Now come back down here to the intersection of these two grid lines and then just click once. Now keep that 1 foot offset, move directly over to your right. Now I know that we're going to need to make some sort of adjustment to this a little bit later on, but we're just going to move over in this direction. Let's just do it down to this grid line right here where we have this grid line intersection at. Next, we're going to move straight on up where we have this intersection here and click again. Now the offset that I want to do for this next one's going to be a little bit bigger. I don't need to have the staircase fill up the entire bay. So in order to be able to handle that, I'd like to have this gap be about 2 feet 8 inches. So the offset here is going to be 2 feet 8. And then move straight over again. And then I'm just going to click on the endpoint of this line. And then hit escape a couple of times to get out of that command. Now it does need to be one continuous line as we go around. So in order to be able to do this, you can just click on the line, select on the little circular shape there, and drag it down to the endpoint. And then click out in the space. Now this is going to be sort of the basis of our opening from here on out. And I do know that our opening is going to be a little bit smaller than this. So what's going to happen is that this line ultimately is going to move over in this direction. But for right now, we're just going to click on the big green check mark. And what this has done up to this point is it actually has created our opening object. And if we take a look at this in a 3D view, then maybe spin this around a little bit so we can start to see through our floor here. We can then zoom in and we can see a couple different openings in our floors. In fact, if we move around just right, we can eventually highlight it and we can see a box there. And that's actually our opening object. Now, the opening has its own set of properties associated with it. Right now, it's told to be -1 feet below the level it's associated with, in this case, the first floor. Well, I don't really want to have a hole in my first floor, so I'm going to change this base offset to be 0 feet 0 inches, or just 0. And I'm going to click here where it has the number 20. Next, it has an unconnected height of 20 feet, which means this height of it's going to go up 20 feet into the air. It's not really what I want to have done, so what I'd like to do is I'd like it to come up basically up to our roof level. So in order to be able to do that, we're going to change the top constraint where it says unconnected right here. And we're going to bring this up to level 10, which is our roof. Now it's already started to make one of the first changes, which is right here with 1-first floor. And when we moved our cursor over here to the right-hand side, you'll see it automatically starts that penetration on up through all the other floors. So now if we end up clicking off into space somewhere and then just zoom out, we can now see that floor opening getting carried up through each and every one of our floor plates going on up in our structure. The next thing we would need to do is we would actually need to come back in here and then start to clean up some of these holes. If we look at this in a 3D view now, in fact, we're technically in a 3D view now, but if we just sort of zoom around here and start to dive in there, we can see that currently we have some structural members that are kind of in our way. Since the structural members are already up on each and every floor, it means that this next move that we're going to do, we would actually have to copy up to each and every floor or make this modification on each and every floor. But I'll show you this just on the second floor, and then we'll know that we would need to do this for all the rest of our floors as well. So we're going to come into our second floor. And then we're going to need to make a modification here. So we're going to be framing around this opening. In fact, we actually need to make this opening the appropriate size for what we need. So to do this, we're going to select on our first structural member over here, which is this W21 by 57. And then I'm going to copy this over. So select on that, come up here to copy, and you can either have it check in multiple or not. In this case, it doesn't matter. Move over here and just pick a base point for where we're going to copy this from. Next, we're going to move over 1 foot 10 inches. And you'll see that it tries to default snap to just 2 feet or 1 foot 6. But as soon as you have that temporary dimension in place, you can type in 1 foot 10 inches. And it'll automatically make a copy of that beam over 1 foot 10 inches. Now, the next thing I want to do is I want to make another copy. And I'm going to copy this one right here, and I'm going to copy it over 8 feet 4 inches to the left. So go ahead and select on it, copy command, 8 feet 4 inches. And we can just type it in as soon as you see that temporary dimension down there. The temporary dimension in this case says 5 foot, but we'll change that to be 8 foot 4 inches. Now we want to clean this particular beam up, and the best way to do that will be to just select on it, click on the little circular shape here, pull it down, do the same thing here, except pull it up. And we might need to adjust it just a little bit if you didn't get the exact location right, and just get it so it's going to be touching each of these different beams that are currently going across. And then finally, we need to clean this one up right here. Now, if you have the little push pin that shows up here, you can just click on the little push pin, click on the little circle, and then just pull it back. Now, the reason why that push pin showed up when we first selected on this is because this was created with a beam system, and this beam was locked to the beam system. So by clicking off the push pin, it means we can modify the beam system a little bit so that that beam is in the right location. Now, the final thing that we're going to need to do is start to make a modification to our opening. And to do that, you select on the opening, click on Edit Sketch, come here to that colored line again, and we're just going to use the Move command because I already know that this is the right distance away. Pick right here in the center of this beam on the right-hand side, and then move it over so that we're going to be now clicking on the center of this beam right here. So it's still the same distance away here as it was over here. And we can click on the big green check mark now that our opening has been resized. Now here on the second floor, we now have the proper structure in place, as well as an opening here in the floors. So it's now framed around and it's going to be structurally sound. So in conclusion, shaft openings are objects that can be moved around, and they'll create penetrations in each floor plate of each floor that they happen to extend through. Just remember that if you're going through this process, though, you're still going to have to make changes to those different structural conditions that frame around them.